Welcome to the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and we are live. If you would like to participate in today's conversation, then I would encourage you to go ahead and comment. We will be able to bring your comments into the broadcast just like we're doing right now. You can feel free to participate, ask any questions or comment, and we look forward to speaking to you. Now, to talk about our subject today, I wanted to introduce our guest because we're going to talk about 3D printing and really how is that impacting heavy-duty parts manufacturers. And so in order to do that, I thought we should bring in a company that's actually using 3D printing in their manufacturing process. So I'd like to introduce to you Eric and Chris from Dorman. Gentlemen, welcome to the show.
Hey, Jamie. How are you doing?
Yeah, glad that you're here. You know, we are live right now, and I'm getting a bit of feedback. So if anybody's watching live, could you just let us know if you're hearing that feedback live? Because otherwise we'll have to adjust, but we'll get the conversation going and go from there. So, Eric, I'd like to kind of start off for those that aren't familiar with Dorman Products. If you could give us a brief overview of your company before we talk about how your company is using 3D printing.
Sure, Jamie. Dorman's been kind of an aftermarket leader for a long time for light duty, heavy duty parts. For us, it's really about kind of creating solutions for our customers and technicians for things that they typically have to go to a dealer to find those parts. So heavy duty specifically, we make a range of parts from fluid reservoirs, bumpers, headlights, engine components, sensors, complex electronics. Pretty much the way our business structure is set up is we have multiple product teams that kind of focus on these kind of rapidly changing markets, and it allows us to kind of move quickly. So if we see a trend or a gap in the market, we're able to kind of quickly jump in that, kind of fill that gap.
Awesome. Well, I appreciate you giving us that overview. We've had some feedback from some live listeners. Doug Dole says no feedback. Thank you very much, Doug, for confirming that. Mr. Singh, thank you also for letting us know that we're doing okay. So appreciate that. I'm interested in kind of understanding a little bit more about the difference between subtractive manufacturing and 3D printing. And for those in the audience who maybe aren't familiar with the differences, Chris, would you be able to explain the differences to us?
Yeah, sure. So subtractive manufacturing or traditional manufacturing, you can think of it as how you would cut a normal part. So if we had a billet of aluminum or some round stock, we're going to cut that down or mill that down or put it on a lathe to make our part. So we're cutting away material to get our end part. With additive in 3D printing, you are building a part layer by layer to achieve your final part. So go ahead.
No, so I was thinking back to my days of when I was a remanufacturer. So we would have to make, let's say, a piston. And so there would be a round bar stock of aluminum, maybe 3 inches in diameter. We'd put it in the lathe and we would have up on the wall, we were doing it conventionally. So we would have all of the measurements and we'd have to come in and remove material. And so when you were done with that part, you had a pile of aluminum curls on the floor at your feet. So that's why it's called subtractive, right? Because you're removing product.
Yes, exactly. Yep.
Okay.
So with additive, we don't have that scrap material after a part's done. We don't have to start with that oversized piece of round stock to achieve that part. So what that gives us the ability to do is it opens up our design freedoms on our design side. So every time that you are designing a part, you need to know how you're going to manufacture that part. So if we're going to have a sand cast that we're going to have to end up machining down to achieve those, we have design limitations within those manufacturing processes. With additive, you don't necessarily have those. You don't have to worry about undercuts or channels that you're not going to be able to remove your mold from when you separate that part. So it's the manufacturing side between your subtraction and your layer by layer build, but also you can look at it, the differences between subtractive and 3D printing from a design side of your design freedoms and design for additive manufacturing.
Right. So, like going back to when I was remanufacturing, straight cuts, a little chamfer, it was easy, right? No problem. You just went in there and you did it with your tooling. But all of a sudden, you start talking about angles. You start talking about, something where maybe there's a hole in the center, but it's not a perfectly round hole, right? It's an oblong shape or something like that. Maybe a manifold or something would be a good visual for people to think about. That becomes very difficult with subtractive manufacturing, traditional manufacturing. It sounds to me like with additive manufacturing, especially for the prototypes or for to see if something fits, it's a lot easier to use that style of manufacturing. Is that correct?
Exactly. Yeah. I mean, you can take everything you knew about subtractive manufacturing and your design limitations, almost completely throw that away, and you can completely rethink how you can design and manufacture parts, where you don't have to worry about those oblong holes or these crazy snake holes through a part that you have no way of drilling or casting. That you can start thinking of designing parts that are never been able to manufacture with a casting or any kind of CNC milling process.
So I see in the background that you actually have some 3D printing equipment there, which is a great visual. Thank you very much for filming in this location. What I was curious about is how has this really impacted the way that Dorman is able to develop its products? Could you give us a little insight into that?
Yeah, so it has completely changed the way that we think about parts. There's some parts that we're always going to design with traditional, but what we're able to do is really think about how we're going to design jigs and fixtures and align testing of parts to test how we do them, and also from the prototyping side and part validation before we send them off to get any kind of tools made.
Early in our planning for this interview, you said that you're going to be able to show us a few examples. Can you show us now while you're in full screen?
Yeah, so we have a part here. It was a timing cover that we were able to print out in 4 different sections on the printer that is directly behind us, our Stratus, to be able to do a full try-on of this part before we sent to get tooling, because tooling would be so expensive on this. So there's the one side of this timing cover.
That's really cool.
Print out and do a full mock-up on the engine and rotating all of our timing chains to make sure there's no interference, nothing. And the great thing of it, we're able to print these parts to our specifications on our drawing. So we know that these parts are going to work how we have them designed. So before we get a tool cut, we can make sure everything's completely fine on our drawings and straight off of our CAD models.
So can you hold that up again, that cover? Because I wanted to kind of point something out. So the only thing that really prevents you from printing that entire piece as one piece is the limitation of the printer itself, right? It wouldn't fit inside the printer behind you. So you had to do it in a couple pieces and then join it together?
Yeah, that's correct. So like I said, the print technology is kind of quickly evolving, and that's right now kind of one of the limitations of it is just the size of the machine, but it's still as accurate and repeatable enough that we could, like you said, print it in multiple sections and just fit those together to kind of do these larger parts. So right now it's really just some of the materials and the size of our machines, but that's quickly changing.
So can you give me another example of where you were able to do something with 3D printing to test fit something? I think you had another example there. Let us talk about that for a minute. So when you're making parts, I mean, you have to validate whether what you're speccing is going to work, correct?
Exactly. So this is a fixture that we designed to check the fit for this turbo uppipe piece here. So again, it's not a really super complex looking part, but there's a lot of tight tolerances and has to have some precision parts because this mounts into 2 hard mounts on there. So there's not much play to get it wrong. So pretty much what we did was we 3D scanned the engine where this actually mounts to, and we designed this fixture to kind of simulate how this mounts into the engine. And it allows us to quickly take our parts, whether they are, prototype samples or actual production parts, make sure that it's going to fit based on the tolerances that we spec, and then say, yes, this part's good. The alternative to this would be, either trying to buy the actual engine and mount it to the engine over and over again, which obviously isn't cost effective or time effective.
Yeah.
So a fixture like this, it might take us, 2 or 3 days to actually do the design, and then another day or so to actually print it out. So in less than a week, we could have a fully used functional gauge to kind of do the part validation there.
So that really explains to me kind of some of the impact that 3D printing is having internally. What about for your overall business development? How does 3D printing, enable Dorman Products to advance its business interests?
It's a great question. So I think we first invested in kind of bringing the printing capability in-house like 8 or 9 years ago. Back then, it was really just using it for kind of what Chris showed for the prototyping. So it's really just using that ability for design validation and kind of the confidence that if you move forward with the design, that you're not going to have to invest in reworking a tool or making these changes downstream. So having the confidence in the engineering, but also the speed. Typically, if we were going to be sending out a finished drawing to get samples made from a tool maker or a manufacturer, that process to not only make the tool could take weeks, and then if you have to make changes, it's a never going process. So having the ability to kind of go quickly too is huge from the prototyping standpoint, and then as I just said, from the gauge standpoint. The alternative to that would be, get it machined out of a block of something, and then you're going to have the limitations that you might not actually be able to mimic that geometry that you want to, just because you can't get a tool in there to cut it. So it really kind of just gives it the opportunity now to again just work quickly, and then kind of moving forward for the next evolution of the business and how we use that is going to be kind of looking for opportunities to use additive manufacturing for actual end use production. So taking it past prototype, and then using it for end use parts. Sounds like you've had experience doing some remanufacturing in the past. So we also do reman parts too, and that's a huge benefit for having the ability, because you might not need 10,000 parts. You might need a part where you only need 50 this week, but you need them this week.
Yeah.
So having the ability to kind of have your CAD model and just go straight from CAD to finished parts in that turnaround time, where it's 50 here, but you might not need another 50 for another 6 months. You don't have to worry about having shelves of dead inventory that may or may not get used. It kind of allows us to be very flexible and agile with those parts there.
Yeah, to me, it almost seems like part of the future is on-demand parts, and I was kind of interested to hear from your perspective as the business development side and the opportunity to enhance profitability and to make the company more efficient. As that expands, we're going to start to see more and more parts in the actual marketplace that have been 3D printed and are now being sold to the end user. It's not just going to be tooling. Is that correct?
Yeah, that's really our goal. And like I said, we have a couple parts that are in development that we're kind of using that approach to. And it's as the 3D printing technology evolves and gets kind of more mature, especially once metal starts getting in the picture, where you can print metal now, but it's not really cost effective. So once that kind of gets more mature, it's really going to open the door for that kind of on-demand manufacturing. I don't think it's really anytime in the near future going to get to a point where you're going to be able to walk into your local shop and have them, have a printer in their back room where they, push go while you're waiting there. But from, the manufacturing standpoint, from the supply chain side, being able to basically have a digital inventory of parts where when you need them, you send out the order and then they get made. Kind of that type of on-demand manufacturing is going to be a reality very soon.
So things that are plastic, things that are interior cab, even under the hood that are plastic, these are the kind of parts that we're going to see first. And then as the technology advances, perhaps then we'll start to see more of the metal components. Is that what I understand is you're saying? Yeah. Okay. So, it's interesting when we look into the future because, Amazon has applied for a patent for a system where the person will order something online and the delivery vehicle is driving around autonomously with a 3D printer in the back. And they print it, and by the time it gets there and is delivered by the drone or the robot or whatever, the part's been made in the back of the van. Like, it's not that people aren't thinking about that eventual future, but it sounds to me like we're a ways away from that, especially with heavy duty parts.
Yeah. You still have to remember that with additive and printing a part, there's always going to be post-processing. And especially for automotive parts, if we focus on a pure automotive,
like automotive or heavy duty, right? Like whether it's a light duty vehicle, medium, or a Class 8 truck, or even heavy equipment.
Yep. So you can take, going back on what we were talking about with subtractive manufacturing. When you print a metal part, and specifically for automotive, you're always going to need some kind of post-processing on that. So, if we have gasket seals, we're not going to be able to print parts that are going to be able to meet those specifications, that we'll have to take in and mill that down to meet that surface finish or meet those tolerances on that part. So even with plastic, you're still going to have some sort of post-processing work if it comes to just cleaning the part up, or some kind of manufacturing process where it comes to putting it on a lathe or milling it in some way to meet those specifications you have. So yeah, I think we will get to that point where you can drive around and have a part delivered to you within, or just go to an automotive store and pick something up. But we are a long way from that. But for production parts, I would think within the next couple of years, we're really going to go to a next level of being able to see a additive production automotive parts in light and heavy duty, pretty all over the board.
Yeah. That, to me, it's fascinating. And you look at different companies, like people that you compete with, just other manufacturers in general. I was really surprised when I heard 8 or 9 years you guys have been using this technology. I think that really shows the proactive nature of your company and how you're looking to really advance your abilities in the marketplace. And that's a great thing. So if people want to work with Dorman, that's the kind of company you are. That's fantastic.
Yeah. Like I said, kind of going forward, we've been with 3D printing for quite some time, but kind of over the past 2 years, it's been, gaining more traction from all the way up to the board of directors in our company. They kind of see this additive manufacturing as a major opportunity to kind of push the business further. So we're constantly making sure we're up to speed on the latest and greatest, what's happening in just the additive manufacturing industry, what a lot of the OEMs are doing. Chris basically focuses his full-time role is just kind of staying on top of 3D printing and additive manufacturing, where he runs all of our internal operations and then kind of just does research on what's going on in the industry. So that way, when we see something that's going to make sense for a business case for us to kind of invest in, we'll be ready to make that move to kind of keep moving forward with that. So
one of the things that I like about the technology is it's not wasteful. Subtractive manufacturing in many ways is wasteful. You could be losing, 50% or more of the actual material used to make a part that lays on the floor at your feet when you're done. So that's really appealing. And so as buyers care more and more about sustainability as we move forward, this is going to be something that will bode well for Dorman to be able to say, look, we use these manufacturing processes, we're remanufacturing, we're using additive manufacturing, we're doing everything we can, not only to boost our bottom line, but also to be more sustainable as a company. And that's why you should buy from Dorman. I think that's a fantastic opportunity for differentiation in the marketplace.
For sure, definitely.
Well, gentlemen, thank you so much for explaining and giving us a little bit of an inside look at what Dorman's doing. I really appreciate that. Thank you very much to both of you.
Yep, thanks for having us.
Yep.
Yep.
You've been watching an episode of the Heavy Duty Parts Report, and we've been live. We've had Eric and Chris from Dorman Products here. And if you'd like to learn more, you can go to dormanproducts.com. It's been a good episode, really interesting to see how our heavy duty parts manufacturing processes are advancing. Next week, we're going to discuss the real big challenge that our industry is facing, trying to overcome the shortage of diesel technicians. And I'm really looking forward to having that conversation. Until then, have a great weekend, and we'll see you next week.